Hey, so welcome everybody. Thank you for coming along this evening. We haven't had a kind of group call for quite a while for the Regenerative Farming Network. So it's nice to get a bunch of people together and listen to a guest speaker. And our guest speaker this evening is somebody that is going to be familiar to everybody. It is David Finlay. I'm sure most of us have met David in one form or another at some point or another. Um, and David has done a whole sort of several years. I think it's taken years, hasn't it? This kind of deep dive into methane, and have bent my ear on it a few times over a drink in a pub and various other places. And so here we are. Yes, you'd asked it if you could present your sort of findings to the group, and so here we are. Um, I think this presentation will take about 20 minutes, you said. Is that right, David? About 20,
I,
25
I,
minutes?
I hope so, yeah.
Yeah.
As long as I don't digress too much.
Yeah. It's only 140 slides. Um,
Yes,
and
hang on
so,
to your seats, folks.
um, after which there will be some time for Q&A and some discussion. If you want to pop questions in the chat as they occur to you, I will go back and monitor those afterwards, or I'll scribble them down so they're kind of noted in your head. But yeah, either way, yeah, lots of time for Q&A afterwards. We'll aim to finish by back of 8, so we can all go and get dinner if we haven't already. Okay, over to you, David. Find that big green share button.
Uh, I've just got a screen here. There we go. Well, anyway, um, I've, it's my screen is filled with the presentation, which is fine. It's easier to read, actually. I could almost read it without my
We
glasses.
we can't see it yet though, so
You can't.
no,
Okay.
you need to press the share button on the Zoom
Well,
screen, like we did
uh,
half an hour ago
yeah,
in the
yeah,
practice run.
my screen is filled with my slide. There's nothing.
Oh, okay. You need to exit presentation mode.
How do I
So,
do that?
well, I normally press escape.
Escape. Okay, there we go.
There we go. And then
Uh,
navigate your way back to the Zoom screen.
um,
Yep. And folks, if you do want to introduce yourselves, because I don't think everybody quite knows each other, so if you want to say hi in the
yeah,
chat, then feel free to do that. And
I've
where
got a
you
horrible
are, who
feeling.
you are, where you are, that kind of thing. Have you found it?
Yeah, nah. I mean, that's typical, isn't it? You go through all the process, everything works,
We had a practice
and
run half an
then
hour ago,
as
everybody.
yeah, and as soon as you went off screen there, my screen filled. There was no icons. I've gone into escape. I've got this share,
Oh, there
but
we go. David
have we
Finley
got
is stuck.
something?
Well, now we can see your emails.
Oh no,
So
that's not
where's the presentation gone?
exactly.
Doesn't
Now it's
look.
asking me to sign in. Sorry, guys.
Honestly, it was flawless earlier. We had a practice run and it was flawless.
Yeah. Um,
Um,
no, I can't even escape. Hang on, I'll take that out.
you might need to stop
Oh.
sharing just to open your presentation again.
No, I've got this Zoom workplace thing, and it says join meeting. You say join meeting,
Yeah,
and
that's your emails, so that's
yeah,
different.
yeah, but it's a pop-up. Oh, sorry, guys. I tried to exit, and it says leave meeting, and said no, I don't really
No,
want to
don't
leave
leave
the
the
meeting.
meeting. No,
If I signed in again, do you think that would get?
no, it doesn't. You don't need to sign in. You're here. You need to
Yeah.
find the presentation. Is it
Uh,
open on
yeah,
your
yeah,
computer?
yeah. Oh, it's disappeared. Ah,
Yeah, that's what I'm saying. I can't see it at the bottom. I can't see a PowerPoint down there.
okay.
So where do you normally
Uh,
have it? Oh,
um,
no, someone's researching
uh,
box schemes.
oops. Oh, dear me. Okay.
Where do you normally have the presentation? Is it in Go? Yeah,
Okay.
it's in doc. There we
There we
go.
go. There
Yeah,
we go.
one
It's
of those.
documents.
It
All
was
right. Oh, four.
phew, cooking on gas.
Come on, come on, come on. Well, I know. It's everybody's waiting with bated breath. So we've got that.
Yes. And then up to
Just
slideshow.
slideshow.
Yeah. And
Gotcha.
then from beginning,
From beginning. Gotcha.
and we're
Have
away.
you have you got that?
Yep.
Right.
So everybody got that? I think everyone should have that. I've got it, so I assume everybody else has.
No, Donald, thank you, Donald. I hope it's a really tricky one.
Oh,
Donald, you're off.
oh, can somebody, everybody,
Oh,
can
yeah.
everyone remember to be muted, please? Someone,
It's a tricky one.
can, sorry,
It
someone's not
relates
muted.
to both,
Hang on,
what
mute,
Michael had to say and what Andrew had to say there.
mute that one. Right, I think we've managed to mute everybody.
Okay.
Yeah,
Right.
all
Well,
good.
plenty of time for people to join. Uh, okay. Right. So what I
David.
want to cover tonight, I'll just run through the slide as I can see it. A bit of climate background and the threat this is likely to bring to ruminant livestock producers, especially the regen guys, from government action to address climate change. Why am I even questioning net zero, especially methane narrative? So I'm going to cover that. What I've found in my search for answers. What is the alternative theory, the primary driver of climate change, and the evidence for that, and the implications arising from this alternative theory? Okay, we need to talk about methane. Well, this is World Resources Institute. Just a couple of weeks ago, the world can't tackle climate change without addressing agriculture. Most agricultural emissions come from methane, potent greenhouse gas that intensifies warming in the near term. So cutting these emissions now could make a fast, significant dent on climate change. Agriculture produces nearly half of global methane emissions, primarily through livestock and rice farming. So that is where we are. That's what's going on in the corridors of power, and that's something I feel we should address. Okay, transitioning in 2018, we were well on our road to transitioning the farm to net zero. And apart from the climate that hit me in the face in the morning, I really knew very little about climate and the drivers of climate and climate change, global warming, other than that it was happening. And again, it was in 2018, saw this video by a retired climate scientist called Walter Yenny, Australian, um, who had been doing work on climate change through the 70s, 80s, and 90s. Unfortunately, it was all in hard copy form and therefore sitting in a filing cabinet somewhere. So he was doing talks online about his findings, and it was all very interesting, fascinating, complex. I sat and watched this thing 3 times, took notes, because it really quite annoyed me because he was claiming that the net zero narrative was had not just an elephant in the room, but a herd of elephants. So that annoyed me because I was heading towards net zero. Questioning this, carbon is the primary driver of climate change narrative. There we are, 3 times. So over the next 4 years, uh, I online and even bought some papers that had been behind paywalls to try and find out whether what he was saying was valid or not. And everything he said really pretty well checked out. We have to realize that the atmospheric carbon as the primary driver of climate change theory is just that. It is a theory. It's a hypothesis. Let's call it the net zero hypothesis. It's not based on real life experimentation. I mean, no one has built a replica atmosphere and fired infrared heat waves at it or ultraviolet or anything. It's all empiric. There's no empirical evidence. It's all based on computer modeling. The Walter Yenny idea, let's call it the Yenny hypothesis, is based on real life experimentation and data. So it's a bit more convincing, to me at least. The net zero hypothesis argues that the increase in greenhouse gases released into the atmosphere from human activities since the Industrial Revolution is the primary driver of climate change, global warming. I just interchange these because basically global warming is driving climate change. The Yeni hypothesis, however, argues that it is human-caused environmental degradation resulting in the loss of evaporative cooling and an increase in long-wave radiation from the surface of the planet, which is trapped by the increasing greenhouse gases in the atmosphere. That is the primary driver of global warming. Okay, so the greenhouse gases are largely found in the first 12 kilometers of the atmosphere, the troposphere. So that's first, that is our thermal blanket. It's a very thin blanket because the diameter of the Earth is 7,500 kilometers, and this is 12 kilometers of blanket. So it's very thin. The short wavelength incoming heat from the sun. So the incoming heat from the sun is short wavelength. It's coming from a very hot heat source, and it is short wavelength, and it largely bypasses the greenhouse gases in the atmosphere. However, the atmospheric gases trap the resulting long wavelength radiated heat into the atmosphere from the warmed surface of the planet. Okay, I'm just going through this sort of basics of the greenhouse effect. The greenhouse gases in the troposphere have been increasing due to human activity, roughly in line with the increasing global temperature. Climate models have been getting more and more complex, incorporating El Nino, La Nina, El Nino, cloud formations, and all sorts of complex things in. But basically, they're still basically predicting global warming based on greenhouse gas in the atmosphere. But they've been getting better till last year, which was actually much more warmer than predicted. So it's based on atmospheric greenhouse gas levels. Much of the research looking at the way greenhouse gas block or absorb radiation, radiated long-wave infrared or IR heat was done back in the 50s. There's a lot of stuff out there that dates back to the 50s. Each greenhouse gas blocks certain parts of the infrared spectrum. So the infrared spectrum that is emitted, the heat emitted from the surface of the planet, it's a spectrum. There's different wavelengths along that spectrum, and the greenhouse gases block different parts of that spectrum. Some gases are much more effective than others. If you ask anyone or anything, AI, ChatGPT, what are the main greenhouse gases? They will reply methane, carbon dioxide, and nitrous oxide. However, I reverted to a science-based platform called CITE, which has access to 1.3, it claims, billion peer-reviewed scientific papers. So that's in the order of molecular absorbency. So each molecule, how effective is it at blocking or absorbing, which is the terminology they use, the following greenhouse gases: CO2, methane, nitrous oxide, and water vapor. So that's the question, put the word in. It replies, number 1 is water vapor. Number 2 is CO2. Number 3 is methane. Number 4 is nitrous oxide. Now, that's very odd, because we're told methane is 80 or 28, depends on the timescales, more powerful than CO2, yet an independent assessment of the research data by a machine with no vested interest has found otherwise. What's going on? The next question might be, okay, what parts of the radiated infrared heat spectrum do these gases actually absorb? The answer is very interesting, because the CITE response shows that water vapor absorbs not only the widest part of the spectrum, but that water vapor blocking overlaps almost entirely with that of methane. Okay, but that might not matter if the methane molecules in the troposphere greatly outnumber those of water vapor. We're reliably informed that methane has shot up by 300% since the Industrial Revolution. That's a scary amount. So that's the next question. So give me the number of molecules of each of the greenhouse gases in the troposphere. Its response is CO2, 413 molecules per million molecules, 413 parts per million. Methane is less than 2 parts per million. Water vapor ranges from 1,000 of rice caps to 40,000 over hot jungle, averaging somewhere around 15 to 25,000 parts per million. It's so variable, they really don't know. So water vapor molecules in the troposphere block the same parts of the infrared radiated heat spectrum and are present as methane and are present around 10,000 times more frequently. Yet we are told that the very powerful greenhouse gas methane leverages the global warming effects of water vapor. It's not just the tail wagging the dog, it's the hair of the tail, in my opinion. So the last question, site. Given the absorbency spectra of water vapor and methane and their relative frequency in the troposphere, would doubling or halving of the amount of methane in the troposphere have any impact on global warming? After mulling it over for a while and spitting out a full reference paper, which it always does, the answer was no. It added that water vapor blocking also overlaps part of the infrared spectrum that CO2 blocks. The CO2 as a greenhouse gas would be compromised. Okay, this raises a couple of fundamental questions. If it isn't the increase in greenhouse gases in the atmosphere that's driving global warming, climate change, what is it? This other driver must be massive to change the global climate, in which case the climate scientists will be factoring it into their models, surely. Well, not really. It does get a passing mention in the 6th IPCC report as the influence of biogeochemical changes on local climates, but the focus of the report with regard to addressing global warming, climate change, remains atmospheric greenhouse gas emissions. So let's have a look at the Yeni hypothesis. So let's step back a wee bit. The incoming sun's heat comes from a very hot surface and its short wavelength heat. It largely bypasses the atmospheric greenhouse gases. This incoming solar heat hits the planet's surface and, as energy can neither be created nor destroyed, is dissipated in various ways. It might be reflected back out in space, and reflected heat is still short wavelength heat and it bypasses the greenhouse gases. It can create thermals, with the hot air rising to the upper atmospheres where it releases the heat out into space. Or it can cause water to evaporate, particularly from forests and particularly from tropical forests, which has a powerful cooling effect on the planet's surface. And finally, it can heat up the surface as it hits and be radiated back into the atmosphere. However, this radiated heat is coming from a relatively cool surface relative to the sun, and its long wavelength infrared heat, which is largely blocked or absorbed by the greenhouse gases in the troposphere. If we look at what's going on with regard to heat energy in a hot jungle, there's a huge amount of evapotranspiration, which is a powerful cooling effect. This evapotranspiration is proportional to the leaf area index, the amount of leaf area per square meter. In mature forests, this is a very high figure, as there are many layers of vegetation in the same area. If the forest is cut down and replaced by crops or grassland, the leaf area index is reduced substantially. A piece of research studied for the first time the impact of tropical deforestation on crops over a 15-year period, 2000 to 2015, from satellite data. They found that over the period there was globally 24 million hectares of tropical forests cleared for crops. Over the course of a year, this resulted in the loss of 60 exajoules, that's 60 times 10 to the 18 joules, of evaporative cooling, and the gain of 40 exajoules, 40 times 10 to the 18, of long-wave heat radiated into the atmosphere. Perhaps not globally significant, but locally, certainly. But that's just the tip of the iceberg. Little joke. If we are considering the cumulative changes in land surface cover since the Industrial Revolution, and we are, that is much more significant. We need to consider not only deforestation, but also over this period, since the Industrial Revolution, but also the huge increases in urban, industrial sprawl, arable land left fallow, hot dry periods, aridification, desertification, the loss of ice cover, increased wildfires, even the heat generated from our use of fossil fuels and nuclear energy. That heat energy eventually ends up being emitted into the atmosphere. It is possible to get a lot of that data online or from our world in data. One very worrying statistic from the December 2024 UN Convention on Desertification is that over the last 30 years alone, 3/4 of global land is experiencing drier conditions, and an area 1/3 bigger than India has gone from being classed as humid to now being classed as dry. A loss to the planet of evaporative cooling and a gain in radiated heat. Using this data and extrapolating from the piece of research that I looked up in the impact of land use change on atmospheric thermodynamics, I come up with a possible total annual increase in long-wave heat being radiated from the surface of the planet into the atmosphere since the Industrial Revolution. So that's the difference per year. So, and over the course of a year, we are emitting an extra 12,900 exajoules of heat energy, of radiated heat energy, long-wave radiated heat energy, or 12.9 zettajoules. That's 12.9 times 10 to the 21st joules. That's 12.9 with 21 zeros after it. It might be a bit less, but it could be a lot more. So is that globally significant? I've heard different numbers quoted for the imbalance between incoming and outgoing heat, but SITE reckons it's about 1 watt per square meter of the area of the top of atmosphere, or 3 watts per square meter at planet surface. So that pretty well fits with what I've heard. If we divide our 12.9 zettajoules of extra heat that we've generated over the course of our recent year by the area of top of atmosphere and the seconds in a year, that gives us about 5 watts per square meter of extra heat we are radiating into the atmosphere over what was being radiated at the beginning of the Industrial Revolution. So yes, it's very significant. But it has to be remembered that oceans buffer a lot of radiated heat. So the fact that it's 5 watts doesn't necessarily, and we're talking about 1 watt as being the imbalance, doesn't necessarily mean that there's any fault there. We need to talk about it. I think it is important not to take away the idea that this might somehow let fossil fuels off the hook. Far from it. They provide us with raw materials to enable us to destroy our planet much faster. Cheap, concentrated energy, whereby we can drive diggers and excavators and plows and cultivators, mining equipment. Then we've got the plastics and the chemicals, and so on. So that, fossil fuels, yeah, they are just as evil as they ever were, maybe more so. So is there any hope? I think so, but not if we waste scarce time, effort, and resources chasing the rainbow of net zero. Under the Yeni hypothesis, the solution is achievable, which I don't think net zero is. Stop deforestation, rebuild the tropical forests, farm regeneratively, plant trees in cities, regreen planet. The benefits from this approach are it addresses climate change, rebuilds biodiversity, rebuilds the water cycle, provides meaningful employment in tropical regions, and addresses the immigration crisis at source. So in conclusion, governments are signed up to cut methane emissions by 30% by 2030. This will be extremely difficult for regen guys, especially organic and pasture-fed, which we are. Net zero is still just a theory and a modeled hypothesis based on the association of the rise in human atmospheric greenhouse gases and global temperature rise. Water in the atmosphere totally dominates atmospheric thermodynamics. Water vapor is the most powerful greenhouse gas. Water vapor blocks the same parts of the radiated heat spectrum as methane. Water vapor molecules outnumber methane molecules in the troposphere 10,000 to 1. Due to human activities, the land is getting drier. Drying land loses the cooling effect of evaporation and gains a heating effect of radiated heat. Radiated heat is trapped by the atmospheric greenhouse gases. The amount of extra heat radiated into the atmosphere from land degraded ecologically since the Industrial Revolution is sufficient to explain much, if not all, of global warming. Addressing global warming, climate change through regreening the planet can address multiple crises facing humanity. Thank you.
Wow, I can't quite believe that was 140 slides.
Well, concentrated.
Very good.
that was 20. Well, it was 20 minutes. Yeah.
So yeah. Oh, still got Wimmer in the background. Thank you, David. It's very insightful. I've scribbled down some comments. I'm not sure if anybody else would like to sort of jump in, put their hands up, put your screens on. Has anybody got anything they'd like to sort of say in response? Stunned them all into silence, David. Oh, you've muted yourself as well.
Well, it's a lot to take on. I mean, you know, it's a belief system change. And believe me, I've had a belief system change on this journey of discovery that I, I find quite alarming, quite shocking, but probably quite explainable. Groupthink is a very powerful thing.
I think for me, there was sort of a comment that you made a few slides back that does this all mean that we should just let fossil fuels off the hook? Which, yeah, I mean, you said no, not at all, which is good. I think that's the risk of this kind of argument is that it's people just go, well, that's fine then. We can just carry on pumping out carbon dioxide and nitrous oxides and methane and water vapor, so long as we regreen the planet at the same time. And I did both my degrees have been climate science based, and both told me that water vapor was the most powerful greenhouse gas. So it was kind of, that's kind of quite basic kind of level for for kind of learning about this stuff when you're learning in any kind of depth. Um, yeah, but I think it's a combination of both. It's a combination of destruction of kind of the green of the planet alongside an increase in greenhouse gases. And it's about the feedback loops and the knock-on effects of one kind of impacting on the other. It's too simplistic and too reductionist, I think, to say that it's nothing to do with emissions and it's everything to do with kind of the sort of ecosystems. It's both. It's absolutely both, in my opinion.
Okay, I don't think it necessarily queries CO2 per se, but the numbers relative to methane and the overlap of the blocking effect does really, to my mind, it doesn't stack up at all.
Sorry, I have an extremely barking dog in the background. Carry on.
Yeah. So the methane argument to me is to say that methane is leveraging water vapor because methane itself is causing warming. The science and math just doesn't support that hypothesis in any way, shape, or form.
So I think you might need to go over that again a little bit. So the water vapor blocks the methane. That's what you're
it's
saying.
blocking the same parts of the electromagnetic spectrum, their infrared spectrum that water vapor blocks. I actually I have on the talk, I have all the graphs and things further down. There's so much data that it is so difficult to do in a short presentation like this. So that's why I just kept it to verbal. But we can go to the relevant graph and show what I mean. But certainly in terms of numbers, in terms of the science, it doesn't support methane at all. It contradicts that completely. Yeah. In fact, I would go as far as to suspect that we are now in a water vapor ecological degradation, very nasty feedback loop. Far more powerful than methane. Methane's irrelevant in my mind, obviously.
Tom has said, could you share the blocking of methane resource, please? First time that he's heard this.
Blocking of methane. Right, how do I get back to my talk again? Share. Okay, we'll share.
Yeah, show us some graphs.
Graphs. Try that one. Uh,
Right.
okay, we've got what? Okay, well, I'll just leave it at that. At least I've got something. Yeah.
How far down do you need to go?
Well, this is actually an interesting one. This is the one which showed the impact of EBF, evergreen broadleaf forest, converted to crop over the 15-year period. And this is the satellite data. So on the left-hand side is loss of cooling. So the green is the loss of the evaporative cooling on the right. The dark shaded areas, the increase in radiated. And this, that's just data. It's not a
Can you make it full
theory,
screen? Because
hypothesis.
it's hard to see when
Uh,
it's
I,
hard to see when it's small.
full screen. I can't
It's
actually
the
see.
slideshow button.
I can't
If you
slideshow.
go to slideshow,
Uh,
like we did earlier,
okay. Slideshow. Right.
and then there's an option for current slide. That's it.
Okay. Right. Well, that's that. Can you see that? Is that any better? No.
No, it's not worked. Didn't
Okay.
don't know why it didn't work.
Slideshow. From current slide.
Hmm,
It's not
weird.
made any difference.
Hmm.
Technology. Anyway, uh,
Um,
this is the one that I can't. Is it's quite interesting because this is showing the greenhouse gases how and what parts of the long wave radiation spectrum they block, and this is water vapor here, and I've drawn a couple of lines either side of the main part of the blocking spectrum of water. Can you see my icon moving that thing? My
yes, we can. Yeah, yeah.
cursor.
The cursor.
Well, and
Yeah.
you go down to methane, and it's entirely inside those two bands. So and you can go to graphs online and over again. I've done that just to check that this is right. And yeah, uh, this was work done way back in the 50s. Howard, well, probably not with us anymore. These guys. What else have we got? Well, photographs. There's that's
Yeah,
showing
we
the
like graphs.
incoming on the left, the red incoming shortwave length, and on the right, the long wave length. And just again, it just goes to show demonstrate this is the methane one. Methane's rather pathetic looking. This is carbon dioxide. So you can see carbon dioxide very effective there, but the overlap with water vapor and methane. Anyway, so
And you've got references for all these graphs. That'd be
well, yeah, that was
yeah.
from Luther University of Iowa, and there are well, this paper's
Yeah, you can see it's the bottom. Interesting.
I can't remember where this one. Oh, yes, it's source publication ResearchGate. And
So,
expand.
Nat, do you want to just unmute and ask your question? Feel free to, or I can ask it for you.
Hi, yeah, sorry, I was in the kitchen.
That's right.
David, you mentioned earlier that Walter Yeni's hypothesis carried out some experiments to try and not just use correlative data for his hypothesis. Can you talk about those experiments and what they
I
found?
I don't know. All I know is what he informs us on his lectures. That's all I know. Because presumably this stuff. I mean, if you watch lecture, I think you've watched the lecture, but if you watch these lectures, he is expounding that stuff. When he does his lectures, he's using chalk on a blackboard. It's so difficult to follow, but it does all actually make sense.
And was any of his work published in peer-reviewed papers, do you know?
I've no idea. I have no idea. I certainly I've never seen any published work done by him when I've been doing my research. No. But the guy knows what he's talking about. That's all I know. And it certainly
it's just hard to justify that to the world when everyone looks at papers as the kind of gold standard for scientific evidence.
Sure. But what I'm doing is I'm following up what he's saying by looking at the research done by others to support or not his contention. And that's all I can do. If his stuff is not in digital form, it's unlikely we'll ever find it.
I feel like he must have. He's been around for a long time, but had been sort of involved in climate science for a long time.
But it's
So I'd be
something that
surprised if he didn't.
Unless somebody uploaded it, it'll be in hard copy.
I mean, he's still alive, still working.
Oh yes.
Yeah.
Oh yeah. Well, yeah, but he's not doing research work. He's doing development work now. Trying to work. He's working with Savory and Christine Jones and people who are on the regen journey.
Tom thinks he's got at least one. See if you can find it. Any other comments, questions, guys?
I would say that when I've checked to see online what the scientific community think about him, they all I can say, the comment I can see are suggest that he's oversimplified the argument, and that's what I get feedback, because I've taken this to the scientists right to the very top, Jim Skee and Piers Forster, and all you get is it's more complicated than that, which of course it is. But these numbers speak for themselves. For me, there is no way I can see how you can justify claiming that methane has any influence on the climate in any way, shape, or form at its present level, or even greatly increased levels, because it's totally overwhelmed by the effects of water vapor in the atmosphere.
Ruth had a question. Do you want to, Ruth, just want to unmute and ask away? And you could stop sharing the screen, David, so we can see each other.
Yeah.
Hi. Yeah. I think I might be a little bit over optimistic on my outlook on the world, but I kind of feel like when people start talking about the fact that it's water vapor and it's our kind of misuse of the land that has caused all this, that it's really great that we can just say, well, what we need to do is just look after our ecosystem better and, start working with nature, and that will provide the solution. So almost like we have all the things we need at our fingertips already provided by nature to readdress the balance, and it will provide us better farming practices, more biodiversity. We on a regenerative journey, we're already doing what we need to be doing, and I feel like that's very reassuring and optimistic thought. But I don't know whether I'm just being overly optimistic. So yeah. I was just like David, are we doomed, or are we actually can we turn this thing around?
If we stop wasting time chasing rainbows, there's a chance. The problem we have with net zero is that people are making a lot of money out of it, and that is a very difficult hurdle to cross. If people are making a lot of money out of net zero, and there's billions being thrown at net zero, then the momentum behind the narrative becomes a problem, and it will be very difficult to address that. I mean, we're on the same journey as you, and what we see here on the farm is that it's all joined up. It makes sense, and you cannot mess with nature without getting negative consequences. And we can constantly try to mess with it because we think we know better, but yes, it is very complex, but it is all joined up. So for me, it makes sense, makes common sense, and it is a solution that we can address. We can actually address these solutions without returning to our caves. That's the worry about net zero. We say, oh, we don't want to give up our flying. We don't want to. Okay, we don't have to do these things necessarily as much, but we could invest all that money and the energy that we have at our fingertips from fossil fuels to do good things rather than bad things, which is what we're doing at the moment. That's my opinion.
We do need to drive down greenhouse gas emissions, but also restore ecosystems. So the two are kind of go hand in hand. Robert, I had a question in the chat. Talis has got her hand up and Judith's waving. So I'm assuming and Richard also. Okay, I think Richard was after Talis. So let's go in that order. Robert, do you want to unmute and to ask your question?
Hi, David. I was slightly intrigued. Well, first of all, I think the whole thing is fascinating, and nothing you said suggests that regenerative farming isn't going to do anything but good on this, even if I don't understand the chemistry or the maths very well. But am I right in thinking you said that water vapor, the world is getting drier, and so there's less evapotranspiration, so less water vapor in the atmosphere?
Yes. Well, no. There is more water vapor in the atmosphere. Water vapor increases by 7%. The IPCC research work, water vapor increases by 7% per degree centigrade increase in atmospheric temperature. So we're talking about if we've got an average of around 20,000 parts per million, and we've increased by 1.2%, 1.2 degrees centigrade since the Industrial Revolution, then we're talking about the math defies me for the moment. I can't think.
Yeah.
But we're talking about a huge number that water vapor has increased dramatically relative to it's probably gone up by something like let's say 20,000 times 8% to 1,600 parts per million. What does methane and increased by 1.5 parts per million? Water vapor has increased by 1,600 parts per million. It blocks the same part of the spectrum, and it vastly overwhelms numerically the methane in the atmosphere.
It doesn't last for as long in the atmosphere, but the sheer
it's
sheer
there.
quantity
It's
of
there.
it.
It doesn't matter in methane.
Yeah.
It doesn't matter, Abby. It's there. Every particle that drops out of the atmosphere, every raindrop is replaced by more that's entering the atmosphere. So a constant churn.
It is relentless. In industry, industry is a big emitter of water
I wouldn't
vapor.
underestimate the forests, but anyway, yeah, okay.
I think we have Talis next.
Yeah, hi. So I'm studying Elaine Ingham's Soil Food Web course at the moment, and part of the course was actually a little bit on Walter Yenne's hypothesis, not in the amount of detail that David's given us tonight, which was fascinating, but I'm familiar with some of this. And just to talk to what Ruth was asking there about optimism, Elaine Ingham actually makes a calculation that, maybe just read it out. And she says, sorry, I'm just finding my piece of my document, that we could reduce the elevated atmospheric carbon and offset annual emissions within 15 years if we actually improved soil health by restoring soil biology. And there is this link that is made between positive soil health and water retention. There's this lovely analogy of good soil being like a piece of a loaf of wholemeal bread that can actually hold water, whereas when his soil is degraded and doesn't have good biology, water just flows off like it would over a pile of flour. And it's the biology in the soil that has a relationship with the atmosphere and creates rain. And when the biology is not there on this in the land, there is no rain because there aren't these nuclei in order to create the rain. So soil health is a way and can do so very quickly to restore land. Just as a positive note there.
Absolutely, yeah. Jenny talks about the soil sponge, and it's the same concept. And in the lecture that he gives in 2018 to one of the universities in America, in California, they have an experiment there where they have soil at various stages of degradation, and the effect of pouring water into each of these columns of soil on what comes out at the bottom. When you've got soil carbon, high soil carbon soil, the water very, very slowly dribbles out at the bottom and it's clear. Whereas you put it into the degraded soils and it washes out the soil. So it is a dramatic, very visual, and very powerful image, just in a simple experiment like that to show how that the lands are getting drier because they're being degraded, the carbon being removed from them, and the water that does fall on them just runs off immediately. It's not stored there. And when it does rain, it rains much more heavily because we've disrupted the life cycles.
Mm-hmm. I think that's something we can probably all agree on this call. I think so, Walter had an interesting conversation quite recently with Dee Dee Pursehouse. I didn't share on the Tuesday email because it was addressing the soil sponge, restoring the soil sponge of California, and it was in a direct response to the sort of recent fires there. But you can probably find it on Dee Dee's website. I'll try and find it in a moment. Judith, you've patiently got your hand up, but Richard was next. so Richard, jump in.
Yeah, as I understand it, water vapor as it evaporates, the transpired water vapor, when it reacts then with solar energy, the result is a free radical called hydroxyl, which in turn, if it reacts with methane, the result of that reaction is to form CO2 plus hydrogen, I think.
Water.
Or water, sorry. So the result of that reaction is more CO2. So in other words, in a sense, the combination of water vapor and methane, far from cancelling each other out, you might say, results in an increase in levels of CO2, which is a much longer lived greenhouse gas, obviously, as we know, than methane. You haven't solved the problem as far as I can see. You've sort of transferred it into another greenhouse gas, and the result is a rise in as a result of the rising emissions of methane is in the end a rise in the levels of CO2. So how have we solved that problem?
Yeah, it's getting into complexities, but I think the argument is that same CO2 is then incorporated through plants photosynthesis into carbohydrates and into foods, and that enters the cycle, the carbon cycle. So the CO2 that is broken down by the hydroxyl ions is part of that cyclical chain, rather than the additional stuff that we've been adding to the atmosphere through burning fossil fuels.
Yeah, I sort of understand that in a sense it joins the carbon cycle, but surely if we are increasing the levels of methane, then we are in effect taking carbon out of the soil, and the result is a sort of level of instability in the carbon cycle. Instead of the carbon cycle staying sort of stable, it's thrown into an unstable state with a rise of CO2 levels. that not the case?
Yeah, um, it's a it, it's very complex. That's what I get told. Yes, well, there will be a rise in CO2, but we're talking about very small numbers in terms of methane relative to CO2 even. About 400 parts per million, 413 or whatever, versus 1.9 of methane. So unless we're talking about vast increases in methane, an increase of one part per million is not actually, it's a percentage wise, it sounds dramatic. It's 50% increase, but in numbers terms, it's relatively insignificant in terms of the overall. I'm not advocating increasing methane anyway. I'm just saying, all I'm saying is that the methane at the moment, the contribution that it makes to climate change is insignificant. It's not a driver of climate change, which it is claimed to be. And that is why governments are signed up to take action against emitters of methane. And they will go for the low-hanging fruit, which is animal ruminants, because that's easy relative to going after the fossil fuel guys. And we've already seen how they're quite happy to throw us into the fire through various changes in local recent legislation.
I think it is dangerously simplistic and reductionist just to not acknowledge the chemical reactions that these different gases have on each other, and how that changes molecules and changes particles and changes the effects that they have in the atmosphere. It's not just like, yeah, okay, methane in itself isn't a big issue, but methane plus other greenhouse gases interacting with. I mean, yes, it's complex. That's the whole point. It's complex.
It is
anyway,
complex.
Judith, you've very, very patiently been waiting for a long time.
Yeah. In my little mind, I just see the role of farming, particularly ruminants, livestock and ruminants, is driving the carbon cycle hard, and driving carbon into the soil. Along with that carbon is the water that's required to hold, in the soil as part of that. Because every microbe, every little beastie in and on the soil, every plant in and on the soil contains a proportion of both carbon and water. And along with those, if you're building that in the soil, you're also building an amount of energy in the chemical molecules that are there. So that is pulling carbon, water, and energy out of the atmosphere back to where nature intended it ought to be. And then you can bring that equilibrium back to where we want it to be. I mean, it's a complex equilibrium with multifaceted things that affect it. But the whole problem is that our thought has been trained in a reductionist, linear kind of system of thinking. And this is all just multifaceted and diverse, complex, with loads and loads of different things that influence it. So for me, the argument has to be, who else can drive carbon and water and energy out of the atmosphere in a oneer? And there's nobody else can do it quicker, more easily, or cheaper, because we run it on photosynthesis. If we're doing it regeneratively, we're not putting industrial chemicals or any of that sort of stuff on the farms, on our fields. And we're running the whole thing just using solar power, which is for free. So I know it's complicated, but it's kind of complicated and simple at the same time, because if you're working with nature, she does most of it for you.
Absolutely. Yeah.
So you get past the complexity of it and say, how did nature do it? How did nature build 10, 15, 20 deep, dark, rich, biologically diverse, complex, functional soils across the Great Plains of the world? over millions of years with billions of herbivores, most of them ruminants. And actually, our job is to facilitate that and do it at speed. And I think we can.
What we didn't have at the same time then was huge quantities of carbon dioxide being pumped into the atmosphere simultaneously.
But
So
going way, way back, the levels of carbon dioxide were actually higher.
yeah. And
You
the
know,
the climate of the planet was wildly different as well.
yeah. But the herbivores can do that. We just undid it over the last 200 years. What we've done to the soils of the Great Plains of the world and arable areas is really pretty amazing.
Not in a good way.
Not in
Yeah.
a good way. Exactly. Yeah. But
Bruce
I
and I have
think
been going on a bit of a tour of Texas on Google Maps on satellite over the last few nights. It's just like, what is
it's
going
stunning.
on there?
It's
What is
stunning.
absolutely
Yeah.
mind-boggling? Like one patch
You
of
know,
land bears no
and
relation
what
to
we
the
can,
next one. It's bizarre.
yeah, what we can do, just increasing organic matter or carbon content of a soil by 1% for, over, it wouldn't be annually, but, just increasing it on an annual basis by a bit. If you could do that on vast acreages, hectareages, whatever you want to say, you could make absolutely enormous difference to the whole world.
That is the problem, though, isn't it? Is a lot of our land management isn't like that. Maybe it more is in this area and large parts
I
of
think,
Scotland,
I,
but
but I think when you see the increase in interest and the increase in attendance at the likes of Groundswell, and it may not be for the sake of greening the planet. I think it's financial. A lot of it's becoming financial and actual. The ability to grow plants is on their own particular farms and they're beginning to realize that maybe others have got answers and they need to research what's out there. And I think there's an interest because they're beginning to realize they can't do it or they're not going to be able to do it in 10, 15, 20 years. So, yeah. But we need to find ways to encourage people to do that faster and more of them.
agreed. Ian and Tom, you've both been chatting in the chat a bit. Ian, do you want to chip in first and share some of what you've been posting?
Yeah, it's a case of where to start, really, isn't it? That there's no doubt that the biggest single driver of the atmospheric temperature around the planet is water vapor. There's no question of that. Like you, I've done an awful lot of academic reading around greenhouse gases, and I think that although Water is onto something, there is definitely an issue with the CO2 concentration. Methane does interfere with the passage of long wave radiation much more strongly than CO2 does. But I think there's an awful lot of uncertainty around methane anyway. When you see it talked about in the mainstream media in particular, it's always spoken about as though there are these really fixed figures that can be quoted and everything's very, very confident. When you actually look at the scientific literature, all of these figures that are quoted have got huge margins of uncertainty on them. So, for instance, the emissions coming from cows has all been calculated based on standard emissions factors that were produced from an intensive dairy cow in a house situation being fed an intensive ration and then scaled up to every cow on the planet. Well, something like getting on for a quarter of the cows on the planet are semi-wild bovines wandering around India. You can't tell me that they're in any way comparable to an intensive dairy cow. But I think, and also, of course, there's been in the last decade or so, since we've been able to remotely monitor methane plumes using infrared videography and some of the satellite systems, the fossil fuel industry has been caught with its pants down, where it's been exposed to have been knowingly emitting an awful lot more methane from its infrastructure than it ever declared. And the national greenhouse gas inventories have all been based on what the fossil fuel industry was declaring they were emitting, not what they were actually emitting. And the way the system has been working, to the best of what I can understand at the moment, is that all of the emissions that have been declared from sources that are accepted as being reliable, like the fossil fuel emissions self-declarations, have been added up. And then what was left was assumed to have come from the biogenic sources. And that's been sort of divvied up between the biogenic sources as best they can, one of which, of course, is ruminant agriculture. So if the fossil fuel emissions have been massively underdeclared, then that surely must mean that the assumption that's been used to work out how much has been coming from ruminant agriculture has been overdeclared quite considerably. But then in any case, there's this whole thing about the short-lived nature of methane in the atmosphere. And that even if we do cut it hard now, and it does provide a limited amount of cooling that offsets some of the ongoing fossil fuels, that only happens for a short period of time. What happens then? I mean, the IPCC themselves said in the sixth assessment report that it's fossil fuels where the action is. And if we don't cut fossil fuels deeply, permanently, and rapidly, then there's no point in cutting methane. And that's being conveniently ignored all the time, because cutting fossil fuel consumption is politically very inconvenient.
And economically.
Yes, yeah.
Yes.
Whereas
it's all about the money.
As we've seen over the last few weeks with or in the last week with, the ending of this year's SFI and things like that, farmers can find it very hard to resist anything when they come under political pressure. We're not a big part of society. We're not particularly influential. We used to be years ago, but we're not anymore. So, methane becomes an easy target.
Yeah. Thank you for that. Tom, you've been posting some bits in the chat as well, pulling a face.
I know Ian quite well, and we sort of interact on the farming forum quite a lot and share all sorts of resources with each other and others. I'm enjoying the level of the discussion, really. I wasn't quite sure what was going to be going on here. We're well aware of Walter Jane and his ideas, and I find them very persuasive indeed. The only thing with Walter Jane is some of his numbers are a bit wild, which kind of undermines his credibility slightly. I've seen lectures where he's saying 2,400 parts per billion for methane, and you just if you just put some more accurate figures in there, you'll be more persuasive. But the whole hydroxyl ion side of it fascinates me endlessly. There is a bit of discussion about whether we've actually got a hydroxyl ion crisis going on, which is part of why the methane levels are going up constantly. And the hydroxyl ion is, of course, the crucial sink for methane. And I'm in discussions with some scientists at DEFRA at the moment about this whole Bovaer carry-on feed additives. There's some really worrying things in there about the increase in hydrogen from ruminants being fed this stuff. And I've been trying to find out from everywhere I can get to about how significant this is and whether any assessment's been done at all. The sort of typical increases in hydrogen are sort of 3 times I've seen 6 times. I've seen 12 times. I've even seen one paper where it's 3,500% increase in hydrogen. And of course, hydrogen gets taken up by hydroxyl ions, so methane no longer gets taken up by the hydroxyl ions, so it increases residency times. Now, I don't know how significant this is, or whether it's just an artifact and isn't actually that important, but it's just, there's a lot of this is just not being looked at, I think. And it's quite worrying, really. The head scientist at DEFRA was aware of the hydrogen, but had no idea whether any assessment had been made of it. So I say there's ongoing discussions there, and I'm basically trying to find out if anyone that will answer me. I've sent various emails out and not had much in the way of response. But yeah. So yeah, enjoying the level of discussion here. Enjoying the participation.
Thanks, Tom. Where are you based, Tom?
Carlisle.
You're Carlisle. Okay.
North of England, yeah.
Yeah, great. Yeah, I'm kind of wondering if we need a sort of more of a kind of working group, because of people are just sort of plugging away doing their own research and trying to engage with different scientists, and maybe it just needs to be a few people getting their heads together and kind of, taking a kind of list of concerns to and just by saying, we are actually a group rather than a sort of farmer by themselves. Sort of taking a list of shared concerns to relevant people, whoever they may be, identifying the right people to take them to, as a sort of what do we do next kind of step. I'm mindful of the time, and we've only got 5 minutes left. Love that Ian keeps popping stats in the chat. More stats in the chat. Has anybody else got anything they would like to sort of pop in as a conversation? So we'll continue the conversation.
I'd just like to raise the other half of the question or discussion, which was the impact of re-radiated infrared heat and the levels that is generating. I mean, that doesn't seem to have been factored in significantly, if at all, into the models, and yet the numbers look incredibly significant at a global level. I don't know if anybody wants to comment for that.
I was too busy imagining cows exploding, which is thanks for that,
was
Ian.
the idea. Yeah, that was the idea. When you say,
I'll be sure not to take any candles into my fields next time I'm out with the cows.
When you say re-radiated infrared radiation, David, are you talking about reflected back to the ground? Can you explain what you're meaning by that?
Well, there was a graph that I showed, which was a horizontal, confusing graph. But I know this is the scientists talk about, and maybe you as well, albedo, and to say, well, albedo increases as we reduce the vegetation cover, therefore there's a cooling effect because that's heat that is bounced back out into space. But it also comes along with increased radiated heat into the atmosphere. So if heat is radiated into the atmosphere from the surface of the planet, it gets trapped and therefore adds to the heating effect in the atmosphere. A lot of that gets radiated back to the surface of the planet. So there's a sort of ongoing shuttle of photons of energy, but eventually they leak out through the window of where they can escape through the certain parts of the spectrum. But it's adding to the heat in the atmosphere. If you've got radiated heat radiating into the atmosphere, that is being captured by the greenhouse gases and is adding to the thermal mass, if you like. And it's substantial. It isn't It isn't nothing. It's substantial. And the researchers in that the paper that I briefly looked at reckoned that the extra heat from 15 years of deforestation at a global level was equivalent to a quarter of a watt per square meter. So, and that's a paper that's peer reviewed. It's been used and referenced because you can check all this stuff up with the site. Luckily, you can look at how valid papers are, so you can actually check out to see whether they are genuine papers and or just figments of people's imagination. But it's an aspect that is being ignored by the science community, I think.
It's a standard part of physical models that the heat radiated back from the surface of the Earth is directly proportional to the temperature of the Earth. And the hotter they talk about black bodies. That's the theory behind it. If you have a perfect black body, then it absorbs all of the heat that's the electromagnetic radiation that's coming in, and then emits. It becomes a perfect emitter and reflects it all back out in terms of the heat that it re-emits. The more that it's able to reflect rather than absorb, the less effectively it's heated. And albedo comes into it because of the more radiation that's actually reflected at the surface rather than heats the surface of the Earth, then the less the surface of the Earth warms, and therefore the less infrared radiation you get re-emitted, because radiation is hitting the Earth in all sorts of different across the whole spectrum: visible light, ultraviolet, infrared, right across the lot. But the Earth only emits infrared radiation, and as I say, that's proportional to the temperature that it's raised to. You're certainly onto something in terms of differences in temperature of the Earth, and it's well established, and it's something that's widely talked about in regenerative circles, that if you leave Earth bare, then in direct sunlight it'll reach much higher temperatures than if you have plant cover over it, and that must alter from the simple physics, that must alter the rate at which it re-emits radiation. It's a while since I've been through a lot of the basis of the climate modelling in the course that I'm running through at the moment, but I'm fairly confident that they are taking account of an awful lot of that. It may be that that it's not being taken account of accurately, and there's a lot of disagreement between models on these things. But certainly it's in there.
What's the course you're doing, Ian? Oh, Tom's found a
I'm
paper.
just coming to the end of an environmental science degree with the Open University.
Oh, okay. Yeah, I didn't mind.
I'll finish it. I'll finish it this summer.
Lovely. I love OU. Tom's found a paper called, what's it called? Accounting for, I missed it.
I think Ian might be referring to that, the loss of albedo from tree cover. They're overestimating the climate positive impact of tree cover because they're significantly underestimating the loss of albedo. I think that's the right way. Is it loss of albedo, increase in albedo? But 81%, it could be up to 81% wrong. That was a paper from 2024.
Yeah, it's a recent paper that was saying that,
then.
Yeah, Hassler et al.
Lots of the assumptions about how much carbon or the reduced impact on the atmosphere through catching carbon in tree cover is offset to some degree by the change in in the effectively the color temperature of the Earth, or the color of the Earth, and therefore the amount of incoming radiation that's reflected. The impact is very small in tropical areas because the the standard ground cover there is actually quite dark. But the further the higher latitudes you get to, the greater the effect is, and it's most noticeable when you start talking about planting conifer forests on permafrost where it's normally snow, because obviously that makes a huge difference to the amount of radiation reflected.
Mhm.
But that paper reckons that even in somewhere like the northern UK and Scotland, it could be reducing the actual warming benefit, or cooling benefit rather, of planting trees by in excess of half. And that hadn't been taken account of in a lot of the certainly a lot of the national plans based around tree planting. Which doesn't mean planting trees is the wrong thing to do if they're the right trees in the right place and they're good for an environmental point of view and everything else. But counting on them to offset ongoing fossil emissions is probably a pretty poor idea.
And then just on conifers, New Zealand study had worked out that terpene releases from conifer forests was increasing methane residency to 15 years instead of 12.
Yeah, I think there's a paper kicking about that was researched for the Scottish government on the carbon sequestration effects of conifer woodlands, and it basically concluded that they didn't they didn't absorb carbon dioxide, partly because of their short lifespan and partly because of the biodiversity loss and change of sort of land use change, etc. And it was conveniently ignored, this paper, and has been consistently conveniently ignored ever since it was written. But I know people that wrote it, or co-wrote it, so I can find it quite easily. Yeah.
That's the worry about a lot of this stuff, though, isn't it? That we're charging off down particular avenues in an attempt at mitigating climate change. And in 20 years' time, we may find that we've thrown large parts of agriculture under the bus and substantially changed the nature of a lot of our landscapes in ways that that were claimed at the time would achieve net zero, but in practice turn out not to.
Mm-hmm.
That's sort of the worst of all worlds, really.
I would add to that the industry is beginning to divide as the threat to methane is advancing, let's say, in that the regen guys are arguing that we're part of the natural carbon cycle, and we are not stocking over and above the level that would be naturally there, historically speaking, because we're working with nature. But the industrial guys are saying, but you look at the methane intensity. I've got a 12,000 litre cow, divide the methane emissions from that 12,000 litre cow, and it's half the emissions from that agroecological 5,000 litre, or less than half, cow. So that is the argument, and that is an argument that DEFRA are picking up on, which is a bit scary for me anyway. And they say, well, if there's going to be taxation, then it should be, or you're going to take cows out of the system, it should be the ones that are least efficient in terms of carbon emission, methane emission. And so you're going to take the people out that are going actually doing good stuff, and increasing the support for those that are destroying the planet.
An interesting counter to that, David, is about the longevity of the cow. Because if a typical highly intensive dairy cow is effectively spent in 3 years, does sort of 3 lactations and then goes to the knacker. Whereas a much lower yielding cow of the sort that you're running, you might get 10, even 12 lactations out of her. Then the proportion of her life before she starts milking becomes a much smaller proportion of her overall life. And those couple of years while she's growing are albeit emitting less methane than when she's adult, because by the fact that she's growing, but there is an offset to some degree there as well. That's an inconvenient message for the intensive boys. And then, of
Yeah,
course, there's all their reliance on high fertilizer use and everything else that backs it all up.
but um, that's creating jobs and growth. That's the problem, and
Yeah,
that's what we're up against.
money again.
I feel like we should wrap up. But I don't want to leave this on a kind of like, and then what? So it'd be nice to have some kind of like concrete next steps, some actions. David, what would you like to happen next? You've initiated the conversation. So what would be your ideal what next kind of scenario?
Well, it's very difficult because um, the net zero narrative is so powerful, and as Jim Ski told me, the train has left. It's not up for discussion anymore, and that's very much uh, the feedback I get. No one in the scientific community are willing to address the questions that I'm raising, and that's very frustrating because I just feel that we're going to get thrown under the bus, and because the argument has gone political, and the politicians, as we've discussed with trees and all the rest, don't care about the realities of what they're doing. They only care about ticking boxes and not losing votes. And so it's very difficult. I mean, how do we as a small group actually make any impact? And can we even agree amongst ourselves? There's even probably doubt there. I'm very skeptical about the methane story. It just doesn't stack for me at all. And I'm not advocating increasing methane, but all I'm saying is that the consequences of addressing methane will be damaging to the environment, in my opinion. So it's an interesting discussion. I mean, it is. We could go down all sorts of rabbit holes. It's endless. I mean, it's so complex and interconnected, but it's trying to avoid losing sight of the forest because we can't see it because of the trees. So I don't know.
So you don't know. Would you like to continue these discussions? Is there general sort of interest, I guess, in continuing these discussions as a group of farmers?
Yeah, I think I'd love to discuss it because it's very hard to find anybody to actually discuss it with.
Yeah.
It's a
Yeah, and as you said, you've tried to make approaches to civil servants and to scientists and basically been shut down. But if like I said earlier, if it was a kind of more of a group approach, but that would mean coming to an agreement as a group first, which is a challenge. Sorry, Judith, was that something in the chat? Did you put something in the chat there, Judith?
It's just that maybe as a group, if we can consolidate our ideas, understanding, knowledge, whatever, and start asking about, are you sure you're going in the right direction? We're so short of time. You can't afford to take a wrong turn. We've been up, different cul-de-sacs already. And if this proves to be wrong, we really are in trouble, that we have to try and encourage somebody somewhere to help back us up, to make sure that the decisions they're making, the policies they're putting in place, the structures and support they're putting in place really are encouraging folk to do the right thing. And I think we have to question that, even if they say the train's left and they're not willing to look at it. If you can put a good enough argument as a big enough group with maybe, I dare I say stakeholders, but or individual politicians or, folk that we can find that can, help support us, or we can become part of a group that's already forming and add our strength to something that's trying to do the same thing.
And allies, I guess maybe the
Yeah.
word. Yeah.
Mhm.
Tom, you just put a link in the chat to the farming forum and a thread on methane there, which goes back to 2021 by the look of things. Just scrolling right down. 64 pages of it. I think that might be the people to talk to. Sounds like a lot of people talking about a similar subject.
Ian was talking about black body and radiated heat, and of course that was Max Planck, a physicist, 100 years ago or so, and one of his famous quotes is, "You will never change a supporter of a leading narrative." Paraphrasing, through reasoned argument. You have to wait till they die. Good luck. That's anyway, it's a bit negative, but there we are.
So, I mean, Tom and Ian, would you suggest that that's a good forum to join? Is it? You just said there, Tom, and that you managed to sort of change AHDB's website piece on methane. That's like that. I mean, yeah, it might take time, but it sounds like an achievement.
It took a long time, that did, yeah, and yeah, we had to correct the numbers they came up with actually, but yeah, that's another story. Just in terms of the actual numbers involved here, the politicians seem to be getting themselves into an awful tiz thinking they're going to do marvellous things with temperatures, and they really aren't. Once you dig into the GWP star aspect of it and what the actual temperature drops would likely be from feeding bovair or reducing, like taking all the cows off the planet, for instance. Somebody had done I don't know the veracity of it, but it was on Twitter about a year ago, and you're looking like you know this, Abby. It used Python code, which I'm not really au fait with what that is. And he basically asked it, if you removed all the cows from the planet, so that's just cows, not beef cattle as well, just cows, what would the temporary drop in temperatures be? And it turned out it would be 0.018 degrees C, so less than 0.02. That's getting rid of a lot of them. But GWP 100 makes it look like you're going to reduce the temperatures by 0.5 degree or 1 degree or something that, it's difficult to get your head round how small this difference would actually be by attacking cows and sheep. And that isn't even being discussed, basically.
Okay.
This is where it's such a shame that the Paris Agreement back in 2015 was framed in the way that it was. The target is a temperature target, but all of the politics around it is about emissions. And there is a reasonable link between emissions and temperature for fossil fuels. But when it comes to biogenic greenhouse gases, the link is nowhere near the same. And with methane, because of the short-lived nature of it, then it's well established under the science around GWP star now that stable emissions are not increasing temperature. And you can argue about past temperature increases, but then that paper that I referred to earlier questions how many ruminants were there on the planet several hundred years ago. The science around that is very, very unclear. And it's well established that, was it something like 35 billion bison were slaughtered on the North American plain? It was ridiculous numbers. And then all of the ruminants that have been lost in parts of Africa and different places around the world. So that's an argument that can be had as to what the baseline is. Whereas methane coming out of the fossil fuel industry is all additional methane. It hasn't been, those carbon atoms haven't been circulating in our atmosphere for something like 350 million years. So even when that degrades, it's still degrading to new carbon atoms circulating in the atmosphere. It's a different thing altogether.
In order to have that conversation, you need to get them to acknowledge in carbon audits that we not only emit methane and carbon dioxide and nitrous oxide, but we also sequester carbon out of the atmosphere into the soil, the plants, our animals, and the ecosystem round about us. And they are singularly failing to do that.
And that's where it starts to get really difficult to avoid the conspiracy theory side of it all. When I don't know how many of you have read Natalie Webster's book, Flawed Figures and Fragile Futures, where she's taken the time to go right back to the start of the United Nations Framework Convention on Climate Change, and looking at how the greenhouse gas accounting system was actually decided in the first place. And that bias, well done, Tom, that bias is there right from the start. Why was sequestration separated out from agricultural production? Why is it agriculture in one group and land use change and forestry in another group? Land use change can be argued to be an inherent part of agriculture in some ways. There's clearly land use change involved in rotational agriculture. But that's not allowed. Any sequestration in there is counted under land use change and forestry rather than under agriculture. And they split the two. It's just an irrational way of doing it. It works for all the other industries because agriculture and forestry are the only two that can actually catch carbon naturally. But the system was written in a way that doesn't allow for that. And that's biased against us right from the start. It's almost as though we were seen as being the likely fall guys for it right from the start, back in the 1980s, 1990s.
Almost as if. Aye, right.
Right, I am going to wrap this up now because it's now 25 to 9 and I've got an email to write to 280 people. So but it sounds like there is appetite to maybe set up a sort of climate discussion group or something. I don't really have capacity to sort of steer that and facilitate it much at the moment. I've got quite a lot else on, but I mean, the people who are here, I guess, are you willing to at least share email addresses and maybe have further online discussions that could generate some kind of key asks? I mean, Tom, you're technically in a different country to the rest of us because we're all in Scotland. So in terms of the politics, like it's a different scenario, I suppose, in some ways,
I
But
hadn't realised that, sorry.
yeah, the rest of us are in Scotland. You're not very far away, but technically that's another country. But that's okay, you're allowed.
I don't see why we can't work with other farmer groups and people that are
totally.
in other parts of the UK or the world
Yeah.
in order to inform one another and strengthen each other's knowledge and understanding. So
Yeah. I was just thinking about the politics and sort of if it's about lobbying, lobbying civil servants, for example, lobbying politicians, then it's a different kind of people.
I'll give Tom a day off that
but
day.
that's fine. So are you happy to share email addresses and at least and so I can make that happen and maybe continue the conversation and if you we sort of link it to the Regen Farm network. That's fine. So Regenerative Farming Network's climate group, and take it from there. Does that sound like a good step forward, David? Is that all right? Gonna have the last words?
Yeah, I mean, it's from small acorns. If you were just going to walk away, then nothing's been achieved. And the question is, can we achieve anything against the momentum that is behind the current narrative? It is so far along the line now, and there's so much politics involved. And as we've talked about already, the politics need not necessarily reflect anything meaningful. It's all about ticking boxes. So yeah, why not? But it's then we're never going to be able to influence anything, but we can possibly feed into those who can influence. I mean, that's the way we can do something. I'd hoped some of the NFU guys would have been here today, but they're not. I approached the NFU and spoke to their climate advisor, specialist, and she said, "Well, you might be right, but my job is to get the industry to transition to net zero."
Who was the climate advisor with the NFU?
Well, it's not. It was NFUS.
Right, okay.
Yeah, I can't remember what her name was, and she was fresh out of uni, sort of wide-eyed and bushy-tailed, and it was just, this is too big. It's too big, and the problem we have also in the NFUS certainly, but NFU possibly as well, is that the counter argument to the net zero argument or methane or whatever is that industrial farming is doing the damage, and they don't like that message.
Exactly.
Yeah. Yeah.
Yeah.
Okay, well, I'm with Ruth. I'm an optimist. So, but I think starting with the conversations is a good place to start.
I don't think we should make the mistake of thinking there are only two camps here, us lot on one side and conspiratorial politicians on the other side. Surely there are a good number of highly reputable scientists, certainly people that I've got a lot of respect for, people like Tim Lenton at Exeter, for example, whose book, System Science, some of you might know, it's a terrific book. So they're there, as it were, standing in the middle. I mean, a lot of those guys will have influence on politicians, but I would like to think that people like Lenton are independently minded enough not to share necessarily in politicians' more ludicrous fantasies and conspiracies. So maybe thinking about people like that we could try and engage with would be one thing to do.
I think so. That's what Judith was saying earlier, is finding the allies, be they politicians, scientists, or anybody else. Yeah, convening allies is a step in that direction. Thank you all for coming and engaging with this conversation. It's really interesting. It has been recorded, so it will probably end up on our YouTube website, just so I can share it back to the other members of the network. Yeah, and let's continue this conversation another time. Thanks, everybody, and have a nice evening.
Thank you.
Thanks a lot.
Yeah.
Cheers.